Hi, welcome to the final presentation video of Team 203 Copycatch project. I am Hariprasad Sivanandam and I will be talking about the system functionalities. I will start with discussing the functionality achievements done by our team. We have developed a web application which has three types of users: students, admin, and professor. Professor can create multiple courses under a particular semester and can add assignments for that. Students can enroll for the course under a particular semester and submit their assignments. The important functionality of our project is to check for plagiarism, and it automatically starts as soon as the student submits their assignments. Comparisons are run incrementally to enhance the performance. When the professor logs into the application, he or she can able to see the plagiarist report by clicking the violation button. All the details of the student who committed plagiarism are available there. Professor can also do a manual comparison for any particular assignments by going into the submission page. There are two types of comparison options available. First one is compare, which picks specific student and does the comparison operation. The second one is compare all, which picks the student assignments for particular submissions and then does the comparison. We also made other additional functionalities for our team project, which is cross-section comparison, cross-semester comparison, and we also added the feature to support multiple language support, which is Python and C++. Plagiarist report details are shared to the professor via email. Moving on to team achievement, the main motive of the application is to detect plagiarism among the students. This application will help the professor to perform the plagiarism check among the students easily. This application is very user friendly and can be accessed anytime they want through mobile and desktop. In addition to the basic requirement, we added more functionalities on top of it to make the professor's life easier. Moving on to discussing the final product for the client. We are confident that all the client requirements accomplished in the development phase. Basic functionalities and strict expectations of the client were given highest preference for maximum satisfaction. Feedback from client representatives during sprint review helped to mold the final product in a desirable form for the client. To provide you with evidence to support our claims, all issues, backlogs, tasks added in Jira has been completed and closed. Different versions of our project enhancement is available in our team's GitHub repo. Sprint reports of the development phase also supports our claim.
Hi, my name is Anju James, and I will be talking about the job quality of our software development process. One of the metrics we used to track quality was a SonarCube quality report. Initially, when we started, our focus was mostly on the security, reliability, and maintainability metrics of the system. We made sure we never compromised on the security aspect of the system. Our system was not vulnerable at any of the stages of the development. We made sure to maintain a grade A throughout the process. The graphs on security, reliability, and maintainability shows we never went beyond A grade. Since our initial focus was the security, reliability, and maintainability to build the system, we relied on peer review to capture possible bugs, and we compromised on the testing. The testing coverage was close to 15% during Sprint 1, and we were facing multiple bugs in DAOs and SQL queries. As we added more code, we started realizing that approach alone won't cut it, and then we started emphasizing on unit and integration test. We realized that by testing earlier, we would be able to detect and solve defects rather than having to resolve them at the end of the process. We focused more on the testing, and the graph shows a transition in our test coverage in the later stages. We made sure all the new code added were accompanied by tests, and we maintained a stable code coverage of over 85% till the last sprint. We maintained our job quality by continuously getting review from teammates. Each of our code went through pull request in Git, and all the team members made sure we read and reviewed the code before approving it. The process of evaluation and refactoring helped and allowed our team to maximize efficiency in merging quality code to the master. Our job quality hence reflected in the final output, where we have made sure we have met all the requirements that were put forward by the client. Thank you.
I'm Karan Sharma, and I'll be presenting the part of process and teamwork. Did the team work as a team? Yes. Creativity thrives when people work together on a team. Starting from phase A till the final day of the project submission, Team 203 has worked hard to achieve the project expectations as stated. The work was divided evenly and fairly, and every team member could finish the tasks that were assigned to them well in time. The team worked with a common vision and towards a common goal that was to develop an efficient plagiarism detector in an agile setting. Did the team use process well or the project was mis or mal organized? Yes, the team used the process well and the project was well organized. As we were working in an agile setting, every day a team used to have scrum meetings either via conference calls or through Slack. We followed the process of creating Jira tickets for any task that we work on starting from sprint 1. Also, team strictly followed using smart commits for changing the status of the Jira tickets and for logging work hours. Was the team able to automate the build, test, and promote processes? Yes. Direct push to the master branch was prohibited. As soon as a member creates a pull request for the changes they made to the code went through the automated build pipeline set up in Jenkins, which comprised of build, test, and sonar quality stages. If and only if all the stages were a success, the code could be merged into the master branch and the WAR file will be deployed on the AWS Elastic Beanstalk server.
Hi, I'm Kirti. I'll be talking about how our team identified shortcomings and how we worked on them. So, during sprint 1, we were not able to correctly estimate how much time we would need to complete all the requirements. This pushed majority of our workload towards the last few days of the sprint. We decided to follow a more systematic approach for the sprints to come. And we held sprint retro and planning meetings and documented minutes of the meetings in Git Wiki. So, typically in a sprint retro, we divided backlogs from the previous sprints, talked about what we could have done better and how we could improve it if it's possible. Also, appreciate any good work that was done during the sprint. In sprint planning, we divided the work for the current sprint, whose progress we would track every day in Scrum meetings, either in person or on Slack. Coming to technology transfer, yes, the system is in shape to be handed over to the client. The installation process for using our application is well documented in GitWiki. We also provided information on a step by step walkthrough of how to use the system from an end user's perspective. The system setup video is clear and concise with explanation about how the client can acquire, install, and use the system. The system demo video would help the client identify and use the best qualities of the running system. Moving to the next question. So, as a part of our Sprint 3 stretch expectations, we demonstrated our application to Professor Jose, the client in our case. He suggested some improvements for future scope, including a social network login, which is a Google, Facebook, or a LinkedIn login. The second recommendation was that our project currently supports GitHub link submission uploads. We could improvise it to add uploads from local file systems as well. We currently offer plagiarism detection for C, C++, and Python files. We could extend the application scope to support other languages, including but not limited to Java, HTML, and JavaScript. Thank you.